Hello, good day, geometry. How's it going? We're going to go over math packet number 5. So you have some tips and tricks to get you started as you work on it. Note the due date. It is due 12/18, which is the Friday, the last Friday we have of school before Christmas break. So if you know that you're not going to be here that Friday, turn it in Thursday or Wednesday or whatever the last day that you'll be here is going to be. All right, so as always, we start with kind of 2 logic-based questions. The first of which says, Millie owns a community pool. Currently, the pool charges $1.20 per swimmer, and an average of 36 swimmers come per day. After doing some research on her customers, Millie discovers that for every 10 cents she raises the price per swimmer, an average of 1 less swimmer comes per day. In order to make her maximum profit, how much should Millie charge, and how many swimmers will come per day? All right, this sounds like a great opportunity for a table, right? So we have the price, we have the swimmers, and we have the profit. And I'm going to start, because we are going to be adjusting this, right? I'm going to start kind of down in the middle here. If Millie charges $1.20 per swimmer, and 36 swimmers come per day, well, $1.20 times 36, she makes a profit of $43.20. Okay. After doing some research, she's noticing that for every 10 cents she raises the price, an average of 1 less swimmer comes. So at $1.30, 10 cents price range or price raise, 1 less swimmer is going to come. How does that affect the profits? Well, $1.30, 1.3 times 35 is $45.50. All right. We're heading in the right direction here. Even though less people are coming, the price change, she's still making a greater profit. What if she goes 1 more, 10 cents more, $1.40? Well, that means that 1 less swimmer is going to come, and 1.4 times 34 is $47.60. Still making a better profit. Okay, and just to kind of see that this follows here, if she lowered the price, that would mean that 1 more swimmer per day is going to come, and 1.1 times 37 is $40.70, which makes sense because that does follow kind of the pattern here that as our price increases, even though our swimmers are decreasing, the profit is still going up. So basically what you're looking for is the tipping point, because obviously at some point here, if the swimmers continue to decrease, at some point you're going to have 0 swimmers coming. And it doesn't matter what the price is, if you have 0 swimmers showing up, you're not going to make any profit at all. So at some point, these profits are going to start to go back down again. And you're essentially looking for that tipping point. What is the price? And how many swimmers will come per day that will get her the maximum profit before the profits start to drop again because she's simply charging too much and not enough swimmers are coming. So you might want to make your table a little bit smaller so you can fit more data here, but this is kind of how you would get started. Make sure you're answering this question here, why your answer makes sense. Put an arrow to your work, verbally explain it. Don't write something like because math or because logic or because it's what I got, my work's on a separate sheet of paper. No. The whole point of these first 2 questions here is for me to see how you are thinking through it. And so make sure that is evident on the page. Next logic question. Nana has enough pancake batter to make 8 pancakes that are each 10 inches in diameter. She has 32 grandchildren and would like for all of them to have a whole pancake. What diameter pancakes should she pour so that every grandchild gets an equal sized pancake? Well, first of all, Nana's got to teach her kids, her grandkids, that life just isn't fair. You're not all going to get the same size pancake, but whatever. So it says she has enough pancake batter to make 8 pancakes that are each 10 inches in diameter. How much pancake batter is that? And since we're talking about pancakes, which are relatively flat, more or less a 2-dimensional shape, you're looking for the total area that 8 pancakes, each with 10 inches diameter, is going to be. And then that area right? So the area of her total pancake batter divided by 32 is going to be the area that each grandchild gets, right? The area. So let's just say that the area of 8 pancakes, each 10 inches in diameter, is 320. So 320, that represents kind of the area of pancake batter that she has, divided by 32 means that each kid is going to get an area of 10 in pancake form. And your job is to figure out, well, what diameter pancake is each kid going to get so that it's an area of 10, right? So you start by figuring out how much total pancake batter she has in area. Divide that by 32 to figure out, well, what size pancake does each grandkid get in terms of area? And then work the formula, the area of a circle, pi r squared, to calculate the diameter size of each pancake. Okay? Next one, 5-card challenge. You can do this on your, actually it's probably better off for you to do your algebra 5-card challenge on this page, since you have to get more points on this page anyway. So 21 points, at least one 5-card combo. You know the drill for that. Calculate the percentage of the figure that is shaded. Yes, the figure includes the rectangle and these sections of the circles also. So it's essentially the rectangle plus 3/4 of a circle plus 3/4 of a circle. I'm using 3/4 because you don't want to count this section twice. It's already part of the rectangle, right? You don't want to count that twice for the total figure. So, but yes, the dotted lines there and those enclosed circles are part of the figure. Okay, so essentially, like we've seen before, right? If you can find the area of both circles and subtract that from the area of the whole figure, then you're going to be left with this shaded section here. Okay, so you need the area of a rectangle, which is base times height. You need the area of a circle, which is pi r squared. Other than that, it's that logic. You know, how do you get those different values that you need to find the areas of the shapes, and then how do you subtract, add, combine, you know, those areas to get the percentage of the figure that is shaded. Next one, the pattern. We talked about this in the algebra video already. Basically, your job is to complete the table, including this section here. So no chart for math packet number 5. Instead, I want you to write an expression, so 3 expressions total, one in each box here in this last row here, representing the number of blue blocks, red blocks, and total blocks in the nth figure. We had to do this once before, I believe, in maybe math packet number 1. So, but let's just talk about the blue blocks here to kind of get you a sense of what I'm looking for. So if we look at the first 4 figures, we see figure 1 has 3 blue blocks in it. Figure 2 has 6. Figure 3 has 9. Figure 4 has 12. So it doesn't take long to see the pattern develop here. We're increasing by 3 each time. So figure 5 will have 15, 18, 21, 24, 27, and 30. And what you're looking for here, when it says write an expression for the number of blue blocks in the nth figure, I want to plug in the figure number into your expression and have the output be the number of blue blocks. So what's the relationship between 1 and 3, the figure number and the number of blue blocks? Between 2 and 6, 3 and 9, 4 and 12, 5 and 15. It probably doesn't take long to realize, oh, hey, I'm just multiplying the figure number by 3. And that gets me the number of blue blocks in each figure, right? So your expression for the nth figure would be 3n, meaning that if I plug in any value for n into that expression, it's going to tell me how many blue blocks would be in that figure. In figure 10, 3 times 10 is 30. We have that written there. In figure 9, 3 times 9, 27. We have that already written there. If I asked you for the 42nd figure, how many blue blocks in the 42nd figure, rather than having to make this table all the way down to the 42nd figure, we can just take 42 times 3, and we can say there are 126 blocks, 126 blue blocks in figure 42. Okay, so that's what you're doing for the red blocks and the total blocks here. You are writing that expression for the number of blue, number of red, and number of total for the nth figure. So you don't have anything to write there. Everything that you need to do is in this table here. Again, working with patterns. That's what algebra is all about, even though you're in geometry. Okay. Next one, surface area of a cylinder. We talked about this one in the algebra packet as well. So take a look at that if you need to. Same thing with volume. I'll write the formula down here. Again, pi r squared times the height. Your question says a cylinder has a height of 32 feet and a volume of 2,010 cubic feet. What is the diameter of the cylinder? So you are taking this volume formula, and I'm giving you the volume. Of course, pi, even though it's written as kind of like a symbol, it does have a value. You know what that value is. Okay. And I give you the height to be 32. So you're essentially solving this equation for the radius, for r, and then using that value to find the diameter of the cylinder. Okay, so kind of similar to our pancake question. You know, that logic question there, kind of similar to CO12 in algebra, where we, solved for certain variables within a formula. But that's what you're doing here. Just make sure that you are answering for the diameter of the cylinder, not the radius. Once you solve for r, there's a little bit of extra work that needs to be done. Then we go on to math exploration. Vincenzo Viviani. Below are several equilateral triangles of different sizes. Equilateral triangles, we'll talk about these in depth in CO25 in geometry, but basically they are triangles where all the sides are the same length. Okay. It says place a point anywhere inside the triangle. Choose a different location each time. So I don't want you to just put it in the middle of every single triangle here. That's lame. Okay. Pick different spots. So if you put it in the middle of the first one, stick it, maybe there. In the second one, maybe in the middle, but up top in the third one, right? It says from this point, draw a perpendicular line to each of the sides. Remember, perpendicular means that it would intersect at a 90 degree angle. So I'll use the big triangle here. From this point, we are drawing a perpendicular line to each side. So straight down. This one's going to be kind of like that, right? You want to create that 90 degree angle there. And this one's going to be like that. Again, create that 90 degree angle. From our triangle to the right here, straight down. This one's going to kind of go like that. And this one is going to kind of go like that. Okay. This one, we got our one going straight down. Then we've got to that side. And again, what we're looking for here is that right angle, right? Okay. Then it says measure in millimeters. So those real small markings on your ruler, not centimeters, but millimeters, each line, and find the sum. So let's just say that in millimeters, this is 10. This one's going to be the same because our point is in the middle. And then we'll say this one looks to be, well, maybe not quite the middle. We'll say this one is 12. Okay. So measure each perpendicular line segment that you make there in millimeters and find the sum. So 10 plus 10 plus 12 is 32. Then measure again in millimeters the height of the triangle. Okay. So to show that better, let's say I did the one to the right here. So let's say this is 2 millimeters. That looks to be about 3. And we'll say this is like 18. Okay, so the sum of that is 23. The sum of our lines is 23. Then I'm going to measure the height of the triangle. So from the top down to the bottom base, and you're going to write that number here. Okay, and you want to make sure your measurements are accurate because you're going to notice something that Vincenzo Viviani noticed back in sometime between 1622 to 1703. Okay, and it's pretty neat, pretty neat. One of the reasons why triangles are my second favorite shape. And then the box here, don't forget about this question here. It says, in what relationship did Viviani and now you find that impressed the mathematical community so much it became known as Viviani's theorem? Just think, if you had been alive back sometime between 1622 to 1703, we might have a theorem named after you if you had found this first. But oh well, missed out. But you have TikTok, so I don't know. Okay. Next one, mean, mean, and mode. We talked about this in the algebra packet. Just make sure that you are only doing it for 7 days. And in fact, similar to the 5-card challenge, if you do it in your algebra packet, you don't need to do it here because obviously you're going to have 2 different sleep totals on the same night, right? So you can pick whether you do this in algebra or geometry. Doesn't make a difference, but no need to do it twice because you're doing the exact same thing in both classes. So then Polyamido question, you've got 12 of them here. Similar to the 5-card challenge, if you do it on this page, you don't need to do it in your algebra packet because it gets kind of repetitive. If you do it in your algebra packet, you also need to do it on this page because this one has you do a little bit more. So yeah, you can save time by just doing it on this page. But if you do complete it in algebra, you also need to do it on this page. And that wraps up geometry packet number 5. It's a good one. It is due December 18th. If you have any other questions, please feel free to let me know. My email inbox is always open. Otherwise, bring with you Monday, work on it over the weekend, turn it in early. I'll check it over, get it back to you with some feedback so you can maximize your point total when it is due on Friday. That's how you math. Don't forget to like and subscribe, and have a tremendous weekend. I'm going to go get myself some Raising Cane's.